Find the integral of x plus 1 to the 1/3. It says to use an appropriate substitution. I don't necessarily see why we need to substitute. I don't know why they want us to use substitution, but since I say use substitution, let u be equal x plus 1, just to be on the safe side. I don't know why. If u is equal to x plus 1, then du is going to be 1 dx. And so let's call this I, even though I didn't label it as I. So I will becomes the integral of, this becomes x plus 1 to the 1/3 is now u to the 1/3 du. And then we know that, okay, all you have to do now is add 1 to the power to get u to the 2/3 divided by the new power of 2/3 plus your constant c. The 1 divided by 2/3, you can write that as 3/2. This is now 3/2, and this is now 3/2. And we're going to have u squared cube rooted plus c. But remember, what was u? U was x plus 1. And so you don't finish there. You need to write that the integral I works out to be 3/2 times, it should be cube root. So it works out to be 3/2 times the cube root of u squared, which is going to be x plus 1 all squared plus c. I don't know why we needed to do substitution. We could have just add 1 to the power. Well, whatever, we did it. Wait, I added, let's check back. I think we made an error here. When we add 1 to the power, 1/3 plus 1. Oh gosh, 1/3 plus 1 is 4/3. 1/3 plus 1 is 4/3. That's embarrassing. My gosh, 1/3 plus 1 is 2/3. This should be 4/3. 4/3. That should be 4/3. That should be divided by 4/3. So then we're going to have a lot of changing to do. So it's going to become 3/4. Going to be 3/4. It's going to be u to the 4. It's going to be x plus 1 to the 4. Oh gosh, my apologies for that mistake. 3/4. 3/4. U to the 4. All right, so now we're good. Okay, let's continue. It says now the diagram below represents a finite region R enclosed in a curve y equal x cubed minus 1. The lines x equals 0 and y equals 0. Calculate the volume of the solid rotating R about the y-axis. Now it says about the y-axis. All right, so we have to remember that volume about the y-axis is equal to pi times the integral of x squared dx. That's volume about the y-axis. X squared dy, sorry. X squared dy. That's volume about y-axis. Remembering, I never said volume about x-axis, volume about y-axis. Now, they told us that y is x cubed minus 1. So what I'm getting is y minus 1 is equal to x cubed. And so I'm getting that x is equal to y minus 1 to the 1/3 power and so what I'm getting then is when I square both sides, I get that x squared is equal to y minus 1, or y plus 1 when I bring it over, plus 1, plus 1. So it's y plus 1 to the 2/3. And I square it, it's y plus 1 to the 2/3. So this is x squared. All right, so that's volume. So this volume is going to be equal to pi times the integral from the volume enclosed here is from minus 1 to 0, from minus 1 to 0 of y plus 1 to the 2/3 dy. That's the volume. So let's work out that now. So the volume works out to be pi times, we're going to work out what that is. Integrating it becomes y plus 1 to the 2/3, you add 1 to the power, 2/3 plus 1, add 1 to the power is to the 5/3. And then you divide by 5/3. And you're going from -1 to 0. Remember, it's multiplied by pi. So let's work this thing out. So let's work out this easy question. So what we're going to get is this is equal to pi times. Now I'm going to factor out 3/5 and write it as 3 pi over 5. And then I'm just going to plug in -1 and 0 in here. So plugging in 0 first, I get 0 plus 1 to the 5/3, which is 1. 1 to anything is 5/3. And I plug in -1, I get -1. -1 plus 0. -1 plus 1 is 0. 0 to the 5/3 is 0. So I get 3 pi by 5 is the volume. 3 pi by 5. And we just have to remember that volume is units cube. Volume is units cube. Units cube. Nice. That's volume. Okay. Part C. So just to let you have a look again at this question. Volume is pi times integral of x squared dy. And volume about y-axis, we're going from -1 to 0. That's volume around y-axis, -1 to 0 of x squared. X squared is y plus 1 to the 2/3 dy. So we can do this. Okay, let's do this question now. It says, given that the integral from 0 to a of f of x is equal to the integral from 0 to a of a minus x, f of a minus x, show that the integral from 0 to 1 of this is equal to 1/2. And we're using, okay, so I like to call it I. So let I I just like to reference them. Let I be equal to the integral from 0 to 1 of e to the x over e to the x plus e to the 1 minus x. So that's what we have. So if this is what we have, what can we do? They said remember to change x to a minus x. So that's also equal to the integral of 0 to 1 of e to the a minus x. In this case, a is 1, so it's going to be e to the 1 minus x over e to the 1 minus x plus, that will become, put x as 1 minus x here, so you just get e to the x dx. Now this doesn't help me a lot. It really doesn't. But I can go ahead and say, well, this is now just the integral of 0 to 1 of e to the 1 minus x over e to the 1 minus x plus e to the x. You're probably saying, but you wrote back the same thing. Not necessarily. Look what I'm going to do. But then I'm going to put a plus e to the x here, and then a minus e to the x here. So I add 1 and subtract back 1, so I didn't trouble the numerator. And they might say, sir, that's crazy. No, if I add 1 to the numerator and subtract 1 from the numerator, I don't do anything wrong. And then I can separate it now. Nice little idea. Then we can separate it as the integral from 0 to 1 of e to the 1 minus x plus e to the x over e to the 1 minus x plus e to the x. But then you have to say, but sir, hold on there. That not cancel each other. Yes, it does. It cancels each other. So this part is fine. Then we're going to have a minus the integral of, separate it as two different integral, no man. Minus the integral of e to the x over, no, instead of writing the denominator this way, I'm going to rewrite the denominator as e to the x plus e to the 1 minus x. Yeah, man. Because addition is commutative. So I don't have to write it as e to the 1 minus x plus e to the x. I can flip it. Now that I flip it, let's see what's going on. Now, as you rightfully called it, this in the numerator will cancel this. So now we're just integrating 1. So this works out to be equal to the integral from 0 to 1 of 1 dx. And then remember, this is now just I. I'm going to write minus I. This part here is just I. Remember, that's how we initially started with, I. And so if you have I is equal to the integral of 0 to 1 of 1 dx, you can bring over the I. And so you're going to get 2I now. So bringing over I, we will get 2I. 2I is equal to the integral from 0 to 1 of 1 dx. So if 2I is equal to the integral from 0 to 1 of 1 dx, that implies that 2I is equal to, when we integrate 1, what you're getting is x And so that is x, and that's going from 0 to 1. So when you work it out, you're going to get 2i is equal to 1. And so you divide through by 2, and so that implies I equal a half. So we've shown that the integral is equal to a half. I is equal to a half. Nice and easy, soft. So finish this easy question. Nice and easy, soft. That's how we do that. All right, part D. Part D says an initial population of 10,000 bacteria grow exponentially. An initial, let's read that again. An initial population of 10,000 grew exponentially at a rate 2% per hour. So it is growing, it is increasing exponentially at a rate of 2% per hour, where f of t is the number of bacteria present hours later. Solve an appropriate differential equation. Show that the number of bacteria present at any time is this. Well, I mean, from they told us that it's growing exponentially, clearly then E is 0 point. Initially, that's going to be 10,000. So this is nice and easy. All right, so they say y is a function of t, and a function of t is the number of bacteria present after t hours. And so what we can do is call it, you have dy by dt, all right, dy by dt will pretty much be the rate. Dy by dt is the rate of the bacteria, and it is increasing. So dy dt is going to be proportional to, it's proportional to dy by dt is proportional to initial population of 10,000 at a rate of 0.02. This is the rate, so we can say it's proportional to this 0.02 t. All right, so that's dy by dt. It's proportional to 0.02 t. What else do we know? We also know that initially it is 10,000 initially, so we can put when t equals 0. We know that the population, when t is 0, y is 10,000. Just writing down all the information. When t is 0, y is 10,000. Just writing down these now. All right, and so if dy by dt is this, then we can say that dy by dt is going to be equal to k times 0.02 t. It's equal to a constant times 0.02 t. And then what we can do is, let me see, bring over the t, divide out the k, and it wouldn't be k either. They said that the rate is proportional to 2% per hour. Population grow exponentially at a rate 2% per hour, where y is the number of bacteria present after t. So actually it's 0.02 t times y. It's 0.02 t times y. All right, so it's 0.02 t times y. Because this is the rate that it's increasing. What's increasing? Number of bacteria after t time. So we can cross multiply the t and divide out the y to get 1 over y dy. 1 over y dy is equal to k times 0.02 t dt. K times 0.02 t dt. All right, now we can integrate both sides. So now we can integrate both sides. Integrating both sides, what we are going to get is 1 over y is ln y, and so ln y is equal to, integrate this side, we're getting 0.02. Why is this t here? It's proportional to 0.02. Proportional to 0.02. So there should be no t, it should just be 0.02. Let me fix this. Nice. All right, so integrate this now, we get 0.02 times k, and then we add 1 to the power to get 0.02 k times t. All right, that's what we get, plus some constant c. But clearly, based on this question, k must equal 1. K must be equal to 1. Clearly from this question, because they only give us one thing, so clearly k must equal to 1. All right, this is an appropriate differential equation. You may end up with something slightly different, but it is appropriate. And so ln y is just 0.02 t plus c. I might ask, so sir, why did I put k as 1? I need e to the 0.02 t. K can't be any other value. So now I can raise it now to e. So e raised to all of this and e raised to all of this. All right, and so e will cancel ln, and so y is equal to e to the 0.02 t, e to the 0.02 t times e to some constant times e to the c. Now, how are we going to find e to the c? E to the c is just some constant. We can call that k. Now, when t is 0, y is 10,000, so we can plug that in. All right, so when y is 10,000, y is 10,000. When t is 0, so it's 10,000. So it's 10,000 is equal to e to the 0, which is 1 times e to the c. So that's your constant, because it's going to be e to the 0, which is 1 times e to the c. All right, so which implies that e to the c is 10,000. That's your constant. E to the c is 10,000. And so just to write it in black now, finally, therefore, just concluding, therefore, y is equal to 10,000 e to the 0.02 e to the 0.02t. Nice and easy, soft. That is why. All right, so finish now. That's it. Nice. All right. Now it says determine the time required for the bacteria of the population to double. Determine the time required for the bacteria population to double. Double means initially it is 10,000. That means now it is 20,000. So we're just solving 20,000. 20,000 is equal to E, which is 10. So it's equal to 10,000 E to the 0.02t. So divide both sides by 10,000 to get 2 is equal to E to the 0.02t. That's what we get now. Let me write this better. (0.02t). So divide by 10,000, we get 2 is equal to E to the 0.02t. Then we take ln of both sides, and so ln2 is equal to taking ln. You're going to get ln2 is equal to ln E is 1, so ln2 is equal to 0.02t. So divide both sides by 0.02, and so t is really just equal to 0.0 ln2 over 0.02. ln2 divided by 0.02. That's t. Nice and easy, soft. So we can work that out. ln2 divided by 0.02. And I'm getting 34.6. So that's 34.7. So it will take roughly 34.7 years to double. Is that years? Let me check. T is in hours. It will take roughly 34.7 hours. It will take roughly 1 day and how many hours in a day again? That's 24. So you have 10.7 hours left. 10.7 hours. It will take roughly 1 day, 10 hours, and 42 minutes to double the size. That's how long it will take. Roughly 1 day, 10 hours, and 42 minutes.